Everyone. Just wanted to take a couple moments to go over a couple different proof examples for proving triangles are congruent and the proofs relating to parts of congruent triangles as well. So the first ones that we're going to be looking at are going to be exclusively dealing with side, 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 and side, angle, side. And we'll go over a couple of little tips to try and help you identify some ways to figure out which one you think it'll be relating to. So let's start with this first proof. Our goal is to prove that the two triangles are congruent. So this is relatively straightforward. And you know when you have to prove that the triangles are congruent, you are going to end with either side, 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 angle, side. Later on, we're going to go over angle, side, angle, and angle, angle, side. But for right now, we are just going to stick with side, 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 or side, angle, side. So just by inspection, before we even move on, let's notice that we are given two sides. And if you look over here, there's not really any information that is going to be giving you angles, right? There's no vertical angles. Vertical angles are really helpful for you to get an angle. There's nothing saying there's a segment bisector. I'm sorry, there's no angle bisectors. There's no parallel lines. Parallel lines are another great way to get angles because you can use the alternate interior, the alternate exterior, things like that. But there's none of those, right? So for right now, we kind of have to assume we're going to be using side, side, side because we don't see a way we can directly get angles. Okay, so let's get started. So we'll set up our statements and our reasons. So our statements and our reasons. Now, again, we do know we are going to start with the given. I'm just going to write them both down here. So we have segment BC is congruent to segment AD, and we are also given that segment AB is congruent to segment CD. Now, if you wanted to actually type this out, if you again, you could insert an equation and do the overbar to get the line over it. You can also do insert special character, right? Special characters, and that's how you can get the congruency symbol. This is also how you can get the triangle. There's a couple other little shortcuts as well, but that's kind of the most straightforward way. All right, so let's go back. So that is our given. All right, so now from here, what do we know? Well, we have two sides, and that does satisfy both side, 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 or side, angle, side. But as we discussed, there's no good way to get an angle. However, this is a shared side. And whenever you have a shared side, that's the really easy way to get the third side, right? So whenever you have that, you pretty much know you're going to be using it, right? It's like a free side, so why not? So we can say that side AC is congruent to side AC, right? It's congruent to itself. And you're probably sitting there and saying, well, this seems unnecessary, and why are we bothering with this? It's really just for meeting that criteria of the postulate for side, side, side. Well, in this case, side, 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 or any of the other postulates that we'd be using, right? We need all three sides in order to invoke the postulate. So this is essentially our way of saying, yep, we have this side because it's clearly congruent to itself. And whenever you do that, that's just the reflexive property. Okay. Now, I have this first set of sides, the one with the one lines. I have this other set of sides, the ones with the two lines, and then the side that is shared is obviously our third side. So we have three sides. Because we have three sides, we can use, or three pairs of sides, I should say, we can use side, side, side congruence to prove that these triangles are congruent. Now, when they're telling you what you need to prove, it is nice because that does mean you automatically know what the congruency statement is going to be. If you did not have that information, you would need to be careful, okay? So, because remember, order does matter when you're dealing with congruency statements. All right. So, we do need to be careful with those. But at this point, we are done with this one, and that one should be straightforward enough, right? Really, the only thing we have to do is use the reflexive property. All right. Now, let's move on to another one. We are now going to ultimately be dealing with this one. And whenever you get two figures like this, I will say it is largely going to be related to triangle congruence, even if it's not directly telling you it's related to triangle congruence, right? So whenever you see triangles, just know that there's a chance you will have to prove triangles are congruent. As we discussed before, proving triangles congruent is really helpful because it gives you all the information because corresponding parts of congruent triangles are congruent, right? So once we know that they're congruent, all the sides we know are the same, and we know that the angles are also congruent. Now, before when we were talking about using side, 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 or side, angle, side, we had said there was no good way to get an angle. And now, as you can see, there's a pretty easy angle that we can get, right? These are vertical angles. So whenever you see vertical angles, that's a great way to get an angle. And don't forget about them because it's kind of easy to forget about them sometimes. And it's a super straightforward way to get that two angles are congruent. All right, so let's just start with what is given. So BD and AC bisect. Well, they bisect each other. That's our given. Now, well, I already spoke a little bit about the vertical angles, but before I do that, I am going to just let's talk about the bisecting. So we're given the information that these two are bisecting each other. So well, what do we know about that? That means that this and this are the same, and then these two are the same. So we have to write that. And because they're saying it says that they bisect each other, that's why I'm able to say both sets. If it only said like AC bisected BD, I would only be able to say that these two are congruent to each other. However, it's telling us that they're bisecting each other, so we know that they're both are going through each other's midpoint. So let's go through this. Well, what do I know? I know that segment AE, well, clearly that's congruent to segment CE. And that just comes from what it means to bisect. And then I also know that segment DE here is congruent to segment BE. Okay. Again, that's just what it means to bisect. Now, at this point, we have two sides, and we already talked about how we were going to get the angle, right? Now, I do need to be specific, right? I can't just say angle E is congruent to angle E because I don't know what that means. I have to be specific. So CED, and we know that that is because of vertical angles. That is my vertical angle theorem. Okay, so now we have an angle in between two sides. So we do need to be careful when we're going to use side, angle, side. We do need the one that is included, the one between the two sides. But now we can say, right? We can now say that these two triangles are congruent. Now, we do need to be careful. Again, it does not directly give us the congruency statement, so I do need to line them up. A, right, A is on the opposite side of this one, so A and C are lined up, D and B, and then E is lined up with itself. So let's just do A, B, E is congruent to triangle C, D, E. And that's from side, angle, side. All right. Last one, right? We've shown that these two triangles are congruent. So what do we know about that? Well, that means all the three sets of sides are that are corresponding are congruent to each other. The angles that are corresponding are congruent to each other. So what are we ultimately trying to show? That AB and CD are congruent. Well, that's easy enough to do. Now that we know that they are congruent triangles, we can just use CPCTC, right? Corresponding parts of congruent triangles are congruent. So we do know that now. So we know that AB, segment AB is congruent to segment CD. And our reasoning behind that is just D, B, C, T, C. And this is a very common way to write a proof involving side angle side. Some other things that you could look for in terms of side angle side would be if you had a angle bisector, if you're given an angle right off the bat, if you have parallel lines, if you have perpendicular lines, that's really helpful because that means you can get right angles. So anything like that is frequently a way to identify that you're going to be dealing with, side angle side so far. And then later on, those will also kind of carry into angle side and side angle side. All right, well, please let me know if you have any questions. I am always happy to do more proofs. And that's all. Have a great day.